Hello, want to learn about local beam search? Local beam search is one of the goal driven informed search techniques. It focuses on the goal and not the path to goal. This is the traveling salesman problem. What is the shortest possible route that visits each city exactly once and returns to the origin city? How can local beam search help us solve this? The search strategy is that it begins with k randomly generated states. Let's assume the starting city is A and k is 2. So, we need to generate two random states. Let's say one state is A to B with heuristic value 20. The other is A to C to D with heuristic value 54. We then need to generate all successors of both states. For the first one, the successor is A to B to C with heuristic value 50 and A to B to D with heuristic value 54. For the second one, there's only one successor, which is A, C, D, B with heuristic value 88. We cannot do A, C, D, A because it needs to get to B first before going back to A. Since we haven't reached the goal, select the best two successors to be expanded. For both states, we can only expand one successor each. A, B, C, D has a heuristic value of 62, while A, B, D, C has a heuristic value of 66. Both successors are still better than A, C, D, B, which has a heuristic value of 88. Since we haven't reached the goal yet, we expand these two. We have now reached the goal. There are two goals generated, so A, B, C, D, A is selected since it has the lowest heuristic value. The parallel search of beam search leads quickly to abandon unfruitful search and moves its resources to where the most progress is being made. Let's look at another example. This time, the 8 puzzle. We want to get from initial state to goal state. Let's assume the heuristic value is the total number of misplaced numbered tiles and k is 2. From the initial state, we generate two random states. Then, for each generated state, we generate another two. When generating a new state, we only choose to move misplaced tiles. This is to ensure that the heuristic value does not increase. From the three generated states, choose two with the lowest heuristic values. Since it is still not the goal, we further generate its successors. Both successors should be expanded. However, for the states on the left, all numbers close to the empty tile is already at the correct place. Therefore, we only expand the right one. We will continue expanding until finally we get to the goal. From the examples, you can see that local beam search is a cross between beam search and concepts from local search algorithm. The drawback is that all k states can become stuck in a small region of the state space. To solve this, we can randomly select k successes instead of choosing best ones. But that's a discussion for another day. Thanks for watching.